Math 7 students. We are beginning a new module today, and the new module is going to be on Expressions and Equations, Module 3. And the first lesson in Module 3 is called Generating Equivalent Expressions, and we find that on page 78 of my comp book. So I'm going to turn there now. And here is page 78. So we'll take a look at this. So up at the top, because we're starting a new module, please write Module 3, Lesson 1. And again, the name of the title is Generating Equivalent Expressions. Our goal for today today we will learn the vocabulary used to create equivalent expressions. The vocabulary is crucial, kiddos. You've got to know what each word means, and if you can't remember it on your own, then you're going to use this comp book to help you, because these terms are very, very important. Question that I need you to be thinking about is, what is the difference between a term and a coefficient? Okay, we'll get there. You'll understand the difference in a little bit. So, things to know. I'm going to go ahead and uncover this, because this is a list of all the vocabulary words that you need to be aware of and that you need to know in order to be successful with working in this module. So, things to know. I made a little table to help us with it, and the first column is the vocabulary word, the second column is the example, and the third column is the definition. I'm going to go through each one, and you need to write down what we have. So, a variable, an example of a variable is a letter, and then the definition is a symbol that represents an unknown amount. A symbol that represents an unknown amount. The symbols that we see most often in our materials that we work with is letters, and usually it's the letter X, L, T, S, so you'll see lots of those being your variables. The next word that you need to be aware of is the word expression. So here's the word expression. This is an example of an expression where we have x plus 8 times the quantity of 1/2. Okay? And the definition is a number sentence that is unsolved with variables or variable and no equal sign. So you can have more than one variable, or you can just have one. The key to understanding expressions is that there is no equal sign. So whenever you see a math sentence that doesn't have an equal sign, that's called an expression. Okay? Equivalent expression is two expressions that equal the same quantity. So an equivalent expression example looks like this. We have 12y divided by 6, and then we have 2 times y. Well, if you solve 12y divided by 6, you get 2y, and if you take 2 times y, you get 2y. So 2y does equal 2y. So that's what makes them equivalent expressions. Okay? The next one that you need to know is the word term. Not only do we need to know it for working with it, but it's also our question. A term tells us the parts of an expression. Okay? So in this example right here, we have 3 different parts, because we have 4x, we have a 7 all by itself, and we have 8y. So there would be 3 terms in this example right here, because none of them are the same. This one has an x, this one has no variable, this one has a y, which is a different variable. So these are 3 different terms because there's 3 different things happening in the sentence. Okay? So terms are parts of an expression. There are 3 of them in this one. Okay? Coefficients. Coefficients are the number that sits next to the variable that is being multiplied. So, is there a variable in this one? So there is no coefficient in here. Is there a variable right here? Yes. The number that is sitting next to it or being multiplied by it is the coefficient. So the coefficient in this expression is 4/9 because 4/9 is being multiplied to y, which is the variable. So it is the number that sits next to the variable that it is being multiplied. Okay? Expression in expanded form. Basically, expression in expanded form is when you have a math sentence that has been broken apart to see all the terms. So instead of it being smushed together or written in a more simplified version, i.e. this one, it is broken apart. So we have 2 a's, a plus a plus B plus B. So we have two A's and we have two B's. In expanded form, we write them all out. In standard form, however, we write what we see. So if we're looking at this one and we're turning it into standard form, we would say there are two A's plus two B's. Okay, that's standard form. This is expanded form. So the definition for an expression in standard form is combined like terms, simplified expression. So you're finding all the ones that are alike and adding them together, all the ones that are alike and adding them together. You cannot combine an A and a B because they are not alike. They do not have the same variable. They have to have the same variable in order to combine them. So expressions in standard form means all of the like terms are put together and all of the other like terms are put together. Okay? The last one that I need you to write down is numerical expression with a value. Okay? With a value makes it have an answer. All right? So another name for a numerical expression with a value is called an equation. So we see 12 minus 4 equals 8. So the expression would be 12 minus 4. The value is 8, and when you put them together, that is an equation because an equation has an equal sign. So a numerical expression with a value is also known as an equation, a math sentence with an answer. Okay? So hopefully that's helpful to you. I don't expect you to remember all of them right this second, but we're going to be spending lots and lots of time working with them, and so hopefully they will start to stick and become a pattern in your mind. So the next thing that we have to talk about briefly in generating equivalent expressions is a lot of times there's a property that we use that becomes very helpful to us, and that property is called the commutative property. I'm hoping that by now you really understand the commutative property because we've been using it a lot. The commutative property tells us no matter the order of the values being added or multiplied, you will get the same answer. So as long as you're adding numbers or multiplying numbers, you can switch the order around and we'll get the same answer. So let's try it and see if this is true. So we have 5 plus 7 plus 3 plus 2. Then we have 7 plus 3 plus 2 plus 5. You will notice that none of the numbers changed. What did change about them was that the order that they were being added. So if we have 5 plus 7, we get 12, plus 3 more is 15, plus 2 more is 17. So the answer that would sit right here is 17. Okay, so now let's do this side. 7 plus 3 is 10, plus 2 is 12, plus 5 is 17. So the answer that sits right here is 17. So now you have to answer this question. Are they the same answers? What do you say? Yes, this one is 17, this one is 17. So they are the same answers. So you just proved that the order doesn't matter how you add numbers. You're going to get the same answer as long as you're adding. Okay, so now let's try it with multiplication. Okay, so we have 4 times 8, which is 32. Times 2 is 64, and then I can't do the rest in my head, so I have to write it on paper. So I have 4 times 8 times 2 times 9. Well, 4 times 8 is 32. 32 times 2 is 64. Now I have to multiply that by 9, and we'll see what we get. 54, 55, 56, 57. So I got 576 is the answer. Okay, so now let's do this side. We have 8 times 9 times 2 times 4. Notice my numbers didn't change. They're exactly the same. They're just in a different order. So now let's see what this one does. Well, I know that 8 times 9 is 72. Then I know that 72 times 2 is 144. Okay? And now I have to multiply that by 4 and see what I get. 4 times 4 is 16. 4 times 4 is 16, 17. 4 times 1 is 4, plus 1 is 5. Ta-da! Are they the same? The answer is yes. So again, your answer that sits right there should be 576. Your answer that sits right here should be 576. And you have proven, yet again, that no matter the order of the values being multiplied, you will get the same answer. So we proved that one as well. Okay, so commutative property, very, very important property to know when you're working with equivalent expressions. Okay, the next thing, these two next things are just reminders because we've been working with these a lot, and you should be able to answer these pretty easily because we've been doing a lot of this lately. Just a reminder that subtraction is the same as adding the opposite. And so here is a way to prove it. We have negative 8 minus 5 is the same as negative 8 plus a negative 5. Well, let's prove it. So we're saying negative 8 minus 5 is equal to negative 8 plus a negative 5. So let's prove it by using what we know. So number line, this says negative 8. So here's 0, 1, 2, 3, 4, 5, 6, 7, 8. There's negative 8. So I start at 0, go to negative 8. Now it says to take away 5. Okay, so I do that. 1, 2, 3, 4, 5. So I take away 5 more. And where do I land? Negative 9, negative 10, negative 11, negative 12, negative 13. So I get to negative 13. So I know that this answer right here is negative 13. Now let's show it with the chips. It says I have 8 negatives. 1, 2, 3, 4, 5, 6, 7, 8. They're all negative. Plus 5 negatives. 1, 2, 3, 4, 5 negatives. How many negatives do we see all together? 13 negatives. Do they match? Yes. So we now learned that subtraction is the same as adding the opposite. What is this number right here? This number was 5. What is the opposite of 5? Negative 5. So again, a reminder, subtraction is the same as adding the opposite. So we just proved that negative 13 equals negative 13. Okay, last one. Division is the same as multiplying by the reciprocal. Division is the same as multiplying by the reciprocal. So we have a way to test it. 12 divided by 4 should be or is the same as 12 times 1/4 because the reciprocal of 4, remember, you have to take 4 and make it a fraction, which would be 4 over 1, right? So the reciprocal means that you trade places. So it would be 12. Instead of dividing, it means multiplying. So remember, division is the same as multiplying by the reciprocal. So we would get times 1/4. Okay, now let's prove it. So what is 12 divided by 4? Everybody. 3. That's a math fact. You should know that. Okay, now let's do this one. What is 12 times 1? 12. What is 1 times 4? 4. What is 12 divided by 4? 3. Do they equal each other? Yes, they do. So again, division is the same as multiplying by the reciprocal. You just proved it. 12 divided by 4 is 3. 12 times 1/4 is 3. So we just proved that that's a true story. Okay? So hopefully this is a good way to get you started. Hopefully you got everything written down. If you didn't, go back and take a look again and make sure you finish it up. Our goal for today we will learn the vocabulary used to create equivalent expressions. Lots and lots of vocabulary, lots of examples. What is the difference between a term and a coefficient? I'm going to leave that up to you, and then when we get back to school in the morning, I would like you to tell me the difference between those two things. They're right here in your book, and the answer is there. All right, that's it, my dears. I hope you have a good one, and I'll see you tomorrow. Bye.